Alright, function notation is just a more sophisticated version of carrying your input values with you. If we have something like y equals 3x plus 5, if we want to determine a y value when x is 3, for example, what is the value of y when x equals 3? Well, you just say y equals 3 times 3 plus 5, y equals 14. So, the ordered pair, x, y, in this case, is the ordered pair 3, 14. Which means, when x is 3, y is 14, and the ordered pair 3, 14 lies on the graph of y equals 3x plus 5. Let's introduce function notation with the same exact graph, except now we're going to say f of x equals 3x plus 5. This is read f of x. So f of x equals 3x plus 5. That means this is y equals 3x plus 5. F of x is y. Y is f of x. They mean the same exact thing. So instead of saying all of this, what is the value of y when x equals 3, take a look at how convenient this notation is. All you have to say here is f of 3. And that's telling you I'm plugging 3 into the function called f. The function f, which is a function of x, is 3x plus 5. So f of 3 is, I'm going to go back to my function called f, and wherever I see an x, I'm going to plug in 3. F of 3 equals 14. Take a look at how much shorter that is. And I even had some notes written in here. So over here I had to write this whole big sentence that says, what is the value of y when x equals 3? Yeah, I ended up with y equals 14. But look how much more abbreviated this version is. This simply says f of 3 is what? Well, f of 3 is 14. And what that's telling you is, when x equals 3, y equals 14. So over here we had the order pair x, y. Now we have the order pair x, f of x, which in this case is still 314. Okay, so x is still your x value, but now our y value we're just going to call f of x. A specific y value is f of 3, for example. Let's do another example here. Let's say we have f of x equals 2x squared minus 4. Let's find f of negative 3. That's telling me to plug in negative 3 into the function called f for x. So, f of negative 3 equals, and now watch how I write this, 2x squared minus 4. I open up a set of parentheses, and now wherever I see an open set of parentheses, I'm going to plug in negative 3. So f of negative 3 equals 2 times 9 minus 4, which is 18 minus 4, 14. So f of negative 3 is 14. Which leads me to believe if I plug the x value, negative 3, into the function f, I get a y value of 14. Let's say I have some function called g, and I'll call it g of x, equals 3x squared minus 2x. Let's find a couple of values. Let's find g of 2, g of negative 3, and g of 2a, g of h plus 1. Okay, so these are 4 different questions here. 1, 2, 3, 4 different parts. But all of these are telling me to plug into the function g. So the function g is defined by 3x squared minus 2x. So for g of 2, I'm simply going to rewrite the rule for g with an open set of parentheses. 3x squared minus 2x. And now what do I plug in there? 2. Three times 4 is 12, and 12 minus 4 is 8. So g of 2 equals 8. Let's find g of negative 3 now. Okay, I'm going to rewrite the rule for g, which is up here. I'm going to say 3x squared minus 2x. And what am I plugging in for x? Negative 3. Let's clean it up. Negative 3 squared is 9. 9 times 3 is 27. Negative 2 times negative 3 is positive 6. Therefore, g of negative 3 is 33. Okay, now the second two parts are a little tricky. Let's find g of 2a now. Again, I'm going to rewrite the rule for g. 3x squared minus 2x with an open set of parentheses instead of x. So 3x squared minus 2x, open set of parentheses instead of x. And now wherever I see an open set, I'm going to plug in 2a. 2a, 2a. Okay, let's square the 2a first before we multiply by 3. 2a squared is 4a squared. And negative 2 times 2a is negative 4a. Clean this up a little more. 3 times 4 is 12a squared minus 4a, and that is all we can do. These are not like terms. I cannot combine them. So far we found g of 2, g of negative 3, and g of 2a. Let's now find g of h plus 1, and this is a tough one. Again, this is telling you to plug h plus 1 into g for x. Okay, so let's rewrite the rule for g. 3x squared minus 2x with an open set of parentheses instead of x. And this helps me determine where I'm plugging in and how many times I'm plugging in. And what am I plugging in? H plus 1. Okay? Now h plus 1 squared is h plus 1 times h plus 1. And just take my word for it, if you go to a piece of scrap paper and FOIL out h plus 1 times h plus 1, it's h squared plus 2h plus 1. Distribute the negative 2, and now we can distribute the 3. And let's combine like terms now. 6h, negative 2h, positive 4h, and then a positive 3 and a negative 2 is a positive 1. And that's function notation. Now you can call the function whatever you want. Typically they'll define f of x is this, g of x is this, but whatever the letter is, you're plugging into that function. So if I said, find f of something down here, I would have to go back to what I defined f as. But because these all said find g of something, g of something, g of something, g of something, I'm using the function called g.